We're live. So today we want to try this problem. LeetCode problem 646, maximum length of pair chain. Okay, it looks like there is sound and I'm sharing. Let's restart the clock. I have no idea what this is about. I just saw that there is like an input, there is an array of arrays. You are given, so let's look at the problem. It's medium level. You are given an array of n pairs where pairs I equals left I, right I. Okay, and left I is smaller than right. Okay, so smaller than a pair P2 is CD follows a pair P1 AB if B is smaller than C. Okay. A chain of pairs can be formed in this fashion. Okay, I'll return the length. Longest chain, which can, okay, the length of the longest chain which can be formed. You do not need to use up all the given intervals. You can select pairs in any order. So it looks like it's this problem is around so in this they also call it sorting of events. And sometimes events have a start time and finish time, so you get intervals there. So what is the longest chain? In this case, the longest. So 1, 2, 2, 3, 3, 4. The longest chain is 1, 2, 3, 4. Longest chain is 2. 2 meaning the longest chain. If B is smaller than C, strictly smaller. So 1, 2, oh, it has to be strictly smaller. That's why the 2, 3 doesn't work. So 1, 2, 3, 4. And the chain, by chain, they mean these pairs. So how many pairs? A chain of pairs, yeah, pairs. 1, 2, 4, 5, 7, 8. Can be. So there are two basic approaches. I mean, one is to sort the pairs, and the other is something else. Okay, n is length, so there's up to 1,000 pairs, and they have values in this range from negative 1,000 to positive 1,000 inclusive. So what's the longest chain? So if we do not sort them, and by the way, it's not the worst idea to do brute force in many cases. And in this case, if we do brute force, we would do the following. We would find the smallest interval. We know that this one is smaller, so we'll go for the smallest second value, and then we will look for in this list the smallest first value that's bigger than this value. So that's linked. Which the value that follows it immediately. And yeah, and by the way, it doesn't say that there couldn't be a case of like that case of, so we have that, but what if we actually have additional, so like let's say 1, 2, 3, 4, and then there will be 3, 5, for example. 3, 5, meaning they have the following, they have the same follow value that follows. Both of these pairs follow the 2. And if there was a 5, 6, in that case, that will count as a chain, and that will not count as a pair, I mean, in the chain, yeah, because it's not linked with this one well, but this does. This does. So that means, but we want to get the longest chain. That means we want to get the smallest, the shortest pair, the shortest. And I mean, if we do brute force, we find one, then we find the value that follows them. Among those, we find the minimum one, the shortest pair, with the smallest, I mean, distance between left and right, and so on. And that's like for each, we'll search the rest. So that's n square. And but another approach is to sort. Like this is already sorted. So we can just go from left, and then we will find the value that follows it, the pair that follows it. We take the first one and go to the next value that follows it, and we count them. It could be. It could be. But what if we have, I mean, as long as the shortest one comes first, it will give us more options. But what if, okay, if this pair actually has more, could it be so that this pair actually offers more? No, it can't be, because this one is actually longer, or either it comes next or it's longer. But actually, no. It could be. There could be another case where this one is actually very long, like that, and then so this will be just one pair, basically. But that, well, this one offers us, in this case, 2 pairs. So it's not enough just to grab the first one. It's not enough because it's important what happens at the exit of the pair. Yeah, the beginning, the start and the end. Let's call it that way, of this pair. Yeah, it's important because this pair could be going like 100, and we definitely don't want to take it. So in that case, what we can do is still go over each pair, but since they're sorted, we'll try each pair and we'll try to build a chain starting from that pair. And that is sorted n square. By the way, n square is just a million, so it's not really that bad. I mean, even without sorting, yeah, the brute force is a million operations. So the brute force is not really that bad. Could be, yeah, without sorting, we can just take the smallest, um, start with the first pair, find the smallest start, then try to build a chain of that. When we try to build a chain of that, what happens? We'll do the search over the rest. Oh, that's it sounds like it's more than n squared. It's more like n cubic, because okay, for this one we will be building, but for building a chain, but each pair requires full search around the rest. So with sorting, we can optimize it and come to n square, because we will be going just after. Because what? Because so we take that pair and we building it. Yeah, it's building it is um, is it linear? Because you see, I mean, if we just take that pair, oh, and see what follows it, like 2, what follows it is 3, and just do this 3, but there are actually 2 3s, and we have the shortest one, so it's better. Yeah, I guess we will have the path in linear mode. So we'll get to n square, yeah, with sorting. Without sorting, we look at that, and we do the search for the follow, find the follow, and then we do the search, the full search for the follow again. Yeah, yeah. So we need to sort them, and that's how we get n square. But can we do better than that? Can we? So I think we see the solution with um, and we see an n and to the point to the power of 3. We see an n square. How about anything n log n? So if we sort, and if we, in this case, what we want to know is the maximum number of pairs, right? Maximum number of pairs. Do we care that it's this pair that starts and ends? Because when we do intervals, like visitors of a website, and they have start and they have and, by the way, here we call them left, right. But yeah, they have that, and and we can have two slices, start and end. And because we know we don't care about what's going on between these. Like, and if we want to know, like, what was the maximum amount of visitors at one, at the same time, we just compute, I mean, starts, and then we so add the starts, we sub, sub, subtract the ends. We don't care what's going on in between them, and we don't care if it's the start of this person or that person, that visitor or that visitor. We don't. In this case, do we care if it's, I mean, could we do that? Could we do something like that? If we just have a slice of left or starts, and then we have a slice of ends, and we do the smallest start and the smallest end. Does it work like that? No, I don't think so, because it's not the same pair. Yeah, like this pair has a smaller start, but it's not, yeah, unlike visitors, which will be they will be overlapping. With chain, we can't do overlapping. then it looks like, yeah, you see we're going after a shorter interval here. And we have then 4, 5. And then we have this twice, 7 twice. Why don't we print the sorted slice? I want to see what it looks like. So once we sorted them, why don't we print the pairs? Font, print, line pairs. Yeah, let us print them and see if the sorting looks right. Oh, oops, pairs. Um, so it was sorted, but in this case we got, yeah, -7, 2, 3, 3, 6, 3, 10. Yeah, it looks like it sorted them right. 1, 2, 3, 4. Why would it be missing it? I mean, obviously we can log that as well and see which one it's missing. So let's say um, let's say we want to font print line, and we want to see pairs. Well, we want to see at least the J. By the way, I want to see print. Let's not do, yeah, let's do print, just not print line. Let's do I and then the rest. Yeah. Oh, yeah, we need to print um, I want to print the line break. So, I mean, the line break would be like that. Geez, why there's so many line breaks? So we got this sorted, then it goes just that. Oh, because, wait a second, we're printing line breaks every time. Yeah, we don't need that many line breaks. So the maximum, okay, so here is the problem. It never, it, for 7, for this 7, -7, it only tried that. It never tried building it with the other ones. Yeah, I had a feeling that that could be a problem because that gives us a little bit more of a cubic cubic uh, complexity. Because, yeah, mm, if we were to, Hmm. Yeah, because I mean, for this one, we will need to try all the sub branches and see which one is longer. So with this one, we will try that. This one, we will try that, and all the sub branches. This one, sub branches. And with this one, by the way, yeah, and we do need to do that, yeah, with each of them. But you see, it looks like a dynamic programming situation because obviously we already solved. Okay, if we look at this one, we already know what's the max length here. So why don't we use that? And we can start. I mean, we can probably go from the end or from the beginning. Like this is the best solution. I mean, for this one. But I mean, if we look here, um, we can tell what's the best solution. Uh, we can store the best solution so far um, with the previous one. Hmm. Yeah, I guess that's the thing. Yeah, we don't. Um, so we need to track. Yeah, the best solution so far. So 701 has the solution. 7 minus 1 is the solution of the longest chain here for 1. So I think we should redo that thing. Um, so let's redo that thing. Let's clean it up a little bit. I mean, that is the best solution in itself. And when we go to the next value, we will check if and we need to check if the next value is actually following the previous value. Then we include that, but it's not. So, I mean, the next value is following, but it's not. It might not be. Like this one is not following that one, which means we wanna from that one. We want to what's the timing? It's 1 hour. I mean, I feel like we're close to the solution. Mhm. I feel like we're pretty close. Um, Okay, the straightforward approach with dynamic programming will be, because I mean, it's kind of logical if we remember what's the best solution, what's the longest for this one. Let's go from the end. It kind of makes more sense for some reason. It's a bit too intuitive, more intuitive. So, I mean, if we know the solution for this and it's 1, then we can try to find the solution for this. And when we look for a solution for that, we will already have a solution for all the subproblems. We don't have to, it's gonna be, yeah, that's how we get to n squared, basically, yeah. So we need to store, yeah, we need to store dp is going to be make slice of integers, and it's going to be the length of pairs, basically. So I mean, we can start from the beginning. It doesn't matter. If we start from the beginning, we know the solution for that. So yeah, we'll be checking all the previous ones. So we have the current is 1. Oh, is I. So, and we'll be checking all the previous ones. So what we're gonna do now? We want to remember. We want to remember. So we want to go over j is going to be 0. J is less than I. All the previous, in this case, it's not going to be anything, but logic is we'll be going over the previous. But we actually will be checking not we'll be checking the dynamic programming for J, and we'll be updating max, not the max, but will be a max. We'll be updating current length, current. What should we be update? Max length, basically. Yeah. Max length. So we know that this particular adds 1. So that is the previous solution plus 1. So we want to know max and max length is Yeah, so and we will so that will be the max. Once we are done going over the previous ones, we'll say the dp for I is max length. In this case, it will be just 1. Yeah. Yeah, that should be better. Current is I. Oh, I never use the current. Because we're just checking out the previous ones, yeah. Oh, yes. So that worked. That and that. So, so we start. I will be going around all of them. J will go from 0 less than I. And it will be checking what's in the DP. Initially, it's nothing. It's not going to be checking anything. What it will do initially, it will say that this first one is 0, but it's not. That's a little problem here. Max length. Well, we can initialize max length as 1 because it's actually at least 1. If pairs only has 1, yeah. So we sorted the pairs. Now, we'll look at the first pair. There's no pairs before it, so we just say that DP is max length, which is 1. Okay, next takes the next pair. The next pair has something to compare, so that will be DP, the previous. But we need to check only if, yeah. We need to make sure that the pairs, I forgot the key, this key, that the pairs I is strictly bigger than the previous pairs. So that's J is the previous one. Yeah. Otherwise, we don't do anything. Yeah. Why? Undefined pair. Oh, pairs. Yeah. So if they're actually following, yeah, it worked. So sorting plus dynamic programming. get a not the fastest, but somewhat good. Uh, it's an hour and 12 minutes. hmm Yeah, a lot of time went on that, but took us some time also to come to the dynamic programming idea also. But overall, I mean, it's not terrible, but something to work on. Yeah, with intervals and with sorting. Um, not to forget dynamic programming. So mm, I think it's a good practice. Um, we should do more problems like that, and we'll see what we have in the next video. So thank you for watching, like and subscribe. Till the next one.